Oh, you just made that. Pessoal, então, trying to speak quickly and slowly at the same time. Pessoal, para quem não conhece, Felix, Lindner, diretamente de Berlim. Diretamente de Berlim. Fala alguma coisa legal para ele. So you thought you were Brazilian, right? So, então vamos lá, gente. Ele vai falar de... Eu não sei o que ele vai falar. Dispositivos móveis, malware e futuro. Quer dizer, a mãe de Nádia de Berlim de vocês. Felix.
So, hello. I'm trying to do this whole thing in English again. So this is going to be funny. I'm German, and nobody here is native speaking. So I try to be speak slow and fast. Anyway, if you think I look a little bit destroyed, that's because I just arrived this morning and I didn't have any slides. So this is the outcome. It's a bit chaotic. And I'm talking about Sh0t malware. Does anyone know what Sh0t malware is? Very good, because I invented the title just 10 minutes ago. So what the fuck? This is actually Louis' idea, so he's to blame. When we hung out in Malaysia, he was like, why don't you come to our thing in Brazil and tell people why the iPhone sucks? Because he was posing off with his Apple iPhone, and I'm like, haha, you loser. So this is why I'm giving a talk here. So we're talking about Symbian, Windows Mobile, iPhone, and BlackBerry in terms of malware and security. So, no, well, they all suck, but some suck less. So essentially, here's my disclaimer. I know a thing or two about Windows Mobile, and I can't tell you why. I know a thing or two about Windows, about BlackBerry, and some of you might know why. I played with the iPhone, and I actually have no real idea about Symbian internals, because that's what I'm using myself, and at some point in time you just have to stop researching, otherwise you wouldn't use any hardware or software anymore. So, talking about malware. What do you need for successful malware to actually function? You need a common execution environment. The problem is, if you don't have a common execution environment, you're writing specific attacks against specific devices all the time, and that won't pay off. You write malware to take a lot of machines at the same time. You need a powerful API, otherwise your malware can't do shit. You need remote vectors, preferably something server, something that open support, that you can talk to, that you can exploit, or a client-side attack, which is common nowadays. You need bandwidth, which is a real problem with mobile devices. I mean, taking over machines on the internet, they have bandwidth. With mobile devices, then it depends on the device. You want minimal containment, so you don't want your software to be sitting in a virtual machine or something. And you need as many stupid users as you can get. So, to show, just an example, Windows XP, common execution environment, check. Powerful API, check. Remote attack vectors, check. Server-side, all Windows client-side. Bandwidth, lots of DSL cable. Minimal containment, stupid users, plenty. Now, another example, Cisco iOS. Remote attack vectors, check. Server-side, it's all broken. Bandwidth, plenty of. Minimal containment, yes, it's not even a real operating system. Common execution environment, powerful API, no. We don't have anything like that on Cisco devices. They have all kinds of different CPUs, over 15,000 different images, no API whatsoever because they're not made for third-party code. Therefore, as shitty as Cisco devices are, we don't see Cisco ones. So essentially, what am I trying to say? as a type of like definition for this talk, you need a large homogeneous distribution of the target platform that you're looking at. It should be available for attack, otherwise how do you get there? Communicate over a channel that you can somehow control, and preferably totally clueless users. So, what about mobile phones? Let's look at mobile attacks in the past. What did we have so far? I don't know how it is here. In Europe, like most of the mobile phone attacks that were actually in the wild and actually like used on many people were commercially oriented, really simple attacks to make money. Most people actually write attacks for fun until they realize they can make money with it, and they make money with it, either like it or white. So the attacks were targeting premium call services and SMS services. So essentially what you did was you sent spoofed SMSs with like a caller ID that was a premium service and posed as a female. Very rare. Never happened before in the internet. And said something like, hey cutie, blah blah blah, let's meet. And if the idiot clicked on reply, then you make money. And the premium SMS service, I don't know what it is here, but like in Germany you can get the premium SMS up to like €6 per single message. So once you send a single message, the receiver gets like €5.85 and the rest goes to the telco. And then we had like really simple parsing bugs early in 2000 something on Nokia, for example, the V-card parsing bugs, which were really entertaining because the V-card is like your business card, your electronic business card that you could send people. And it's like really name colon Lindner, first name colon Felix, something. And if you would send a Nokia something like nothing colon nothing, it would just die. So they were like really trivial, but they were also misused because people would call you and then send you such a V card and you couldn't hook up because your phone died, and so your phone would still be connected. And then there were parsing bugs and things like JAT files. Nobody knows JAT. I assume JAT is a Java description file that you ship to your Java applications when you want to put them onto the mobile phone. It was never really used, but of course the parser was broken into Siemens files. And then there were less known attacks, like one of the less known attacks is screen overlay, which has some relevance today because people are starting to install games on their mobile phones. Essentially what you do is, the attacker writes Java code to occupy your screen when your phone tries to tell you something important. We were the first to find this out in 2002. JVM attack on Symbian worked that way, so essentially the drawing on the screen was asynchronous, and you had a race condition. So the Java code could say, do something that requires user permission, and in the next line would say, draw to the screen. And the operating system would be too slow to actually make the context switch fast enough, and then it will kick off the thread that would draw to the screen, and before that, send a pop-up saying, here user, do you want to do this and that, like send an SMS message. And so the pop-up would be there, and the keys would be configured for the pop-up, but then your screen drawing would happen. And you can do the same thing in Flash. I can imagine it's hard to think how this goes. So those are actually screenshots from the emulator. So this is the message box it tries to say, and this is where you overlay it with. And you can also overlay it with like a racing game where here's left and here's right, and then the user has a 50% chance of like clicking on yes, and every time he tries to turn left, you get a premium SMS sent. Then there are other attacks that are, I just learned about that one last week. It was really hush-hush, so this is totally unpublished. SIM toolkits are something that's rarely used nowadays, but it's still on all the SIM cards. You might actually know in GSM that there's a strict separation between the SIM card and the so-called terminal equipment, which is your phone. And the GSM people are really proud of it, and rightfully so, because it protects all your private data and your key material from an actual stupid phone. The thing is, there is of course a way into your SIM card over the phone, which is the SIM toolkit. So the providers can take a SIM toolkit and configure value-added menu entries on your SIM card. It was used with the old Nokia phones. You would have an extra menu saying like, send me joke of the day or send me stock prices or something per SMS. That was like pre-GPRS times. And those are configured with a SIM toolkit. Now the problem here is that the provider is actually responsible for having a shared secret between the SIM card and himself. Now, from a commercial point of view, this is really complicated because they buy the SIM cards in like millions of packages from somewhere Taiwan, and then they like customize them slightly and send them out to all the shops. And then you have the resellers, for example, that would go and have their own SIM cards and just buy airtime from the major mobile providers. So the whole concept of the shared secret on the SIM card is totally toast. So essentially what happened nowadays is that people would get hold on a SIM toolkit that the providers are really trying to keep under the table, but you know how well it works if someone has a piece of software and says nobody else is going to get it. That never worked. So people got hands on the SIM card toolkit and will actually send a plain configuration SMS to your SIM card saying do nothing, but once you're done with doing nothing, please send me an acknowledgement. And the acknowledgement would go to a premium SMS number. So at the end of the day, they can send you as many SMSs as they want, you wouldn't notice. Maximum your battery goes slightly down, but you actually have huge charges on premium SMS on your bill next month. So before we go into this whole malware thing, let's quickly talk about mobile phone security models, because I don't think many people know about like what the different security models on the four major systems are. The driving factors for mobile phone security are actually not protecting the user. Forget about that. Nobody ever invented security to protect the user. The players that are really interested in securing mobile phones is the mobile phone vendor, who makes the hardware, the operating system vendor, and the GSM provider. So the phone vendor actually must include binary code that they obtain from some third party into the mobile phone to make all the chipsets that they bought from Taiwan and China and anywhere else to actually work. So there's the GSM chipset, radio chipset, Bluetooth, ERDA, what have you. And they get binary distribution driver sets for the chipsets that need to be in the phone, that need to be not to be modified by anyone, and are loaded onto the chips every time you power the phone on from a unpowered state. Then you have the OS vendor, who actually has to protect the operating system. And the reason for that is because otherwise the providers wouldn't buy it. So the operating system must be protected from modifications so the providers can actually put their requirements on it. And all the work therefore goes into the bootloader. Because the bootloader is the only thing that they're really interested in. They want the same images loaded all the time. And they have no control over the third-party code that we had in the slide before, like all the chipset code. So that goes into the operating system, but it's not verified. They also have no control over the hardware design, because the operating system vendor just makes the operating system and doesn't care about the hardware design as long as the hardware is capable of running this operating system. Sometimes they don't even have information about how the hardware works. As long as the driver works with the hardware, that's fine. How it works and why it works, they wouldn't know. And then, on the other hand, the operating system vendor wants to open the phone to legitimate third-party applications because that increases the market share. The provider, last of the three, is the one who considers the mobile phone his extended point of sale. And this is like the whole business model besides actually making money with phone calls and time. Because that goes down. Everyone knows that like the call times and the money that you pay for it goes down all the time. So they are looking for additional business models, and everything that's like value added is what, at least in Europe right now, makes the money, because nobody in Europe actually pays lots of money for the minutes, the air minutes that he's on the phone. Most people in our company actually have a flat rate, so we can be on the phone 24/7 if we want, but we don't want to. But then again, there's people like, in Europe we have Jamba, who are like the most stupid shop on earth. They run TV ads and MTV all the time, where they say, have the following song as your ringtone, and then it costs you like €3 to download it. So that's where the provider actually makes the money, because he's like the middleman in this transaction, makes a portion of it. Same as for games and everything else that a sane person would not have on a mobile phone that everyone else wants. So the solution for them is essentially to use a certificate-based approach, which used to be cool when nobody knew how complicated certificate handling actually is. So the maker, the vendor, and the provider, everyone has a cert, and all three put it into the phone. And depending on the certificate you sign your code or your package with, you can install different things. And if you have a mobile phone, looking into the certificate store of your mobile phone can actually be really, really interesting. Because in some distributions, let's say you buy an HTC phone in China and you run it here, it would be interesting to look into your certificate store and maybe find a few certificates that have write access to your GSM and voice control codec chipsets, where you can't even Google the company that issued the certificate, which is usually a very good indication that you need a new phone. And everything else that's not signed is actually distributed by Java. So the idea is that you have a concept like a browser applet that cannot interfere with your mobile phone and is used for all the bullshit that everyone else wants, like games. Now, how does that work in detail? On Symbian, you have something called a vendor ID. And you have to go to Symbian people and say, I need a vendor ID, and then you have to submit it to an independent test house, whatever that might be, and list the, quote, ways the software can access the system, unquote. This is from the Symbian Developers Handbook security section, so I'm just quoting it here. The test house then verifies that there are no other ways that your software can access the mobile phone. And those capabilities, as they call it, are put into the package together with your code, and then it gets signed by the verification house, and then your loader of the operating system verifies that everything is fine, and the code runs. So this is how it is supposed to work and look like. And to tell you the truth, I didn't try it, I didn't test it, and I didn't believe it. Because in reality, everyone turns off signature checking. First thing you buy a Nokia, Symbian, you turn off signature checking. Why? Because otherwise you wouldn't be able to install themes that are published on the internet. And damn, I have a mobile phone with GPRS, I want SSH on it. And SSH isn't signed, PuTTY isn't signed by Nokia or Symbian, so I turn off signature checking. Now, code signing on Windows Mobile is a comparable process. So there's no general certificate. It really depends on the distribution you're looking at. And the certificate set depends on the set of players you're playing with. Microsoft could go ahead and sign code for you. I don't know if they actually do that. I don't think they do. The provider can sign code for you, like Vodafone or whoever you have here. And the procedure, of course, depends on what the provider finds interesting. So if you have a fucked up mobile phone provider, and you can just walk up to them and say, could you sign this app, please? They will probably do it if they don't know what they are doing. Now, the reality is this. On Windows Mobile, you have 3 different privilege levels. One is called unprivileged, the next one is called privileged, and the third, obviously, is the operating system kernel. Now, in fact, you only have 2, because from a privileged process into the operating system kernel is 1 syscall. So a privileged process can say, make me kernel, and he will be kernel. So essentially, you're left with two privilege levels, and the signature is a authenticate signature that you all have seen in Windows XP and Vista. Like, check this binary, verify signature, Microsoft made it cool. So that mechanism actually works and is verified on application load. So you start an exe file, it goes ahead and says, okay, here's the signature of the exe file. Now let's check the phone requirement. In the phone, requirement is set by the provider again, and you can say, I want the binaries to be signed to run at all, or I want them to be signed to run in privilege mode. Both very common settings. It's really hard to say what providers do. It changes from release to release. In reality, again, almost nobody cares about privileged binaries on Windows Mobile, because what's clever about Windows Mobile with the unprivileged binaries is the only thing that people want to download is games and themes. Games don't need to be privileged, themes are not even signed. So how does it work on BlackBerry? BlackBerry is the most restrictive environment, I can say right up front. RIM is the only company that can actually give you a signature to run code on a BlackBerry. No matter where you bought the BlackBerry, it could be that, like, if you have a T-Mobile BlackBerry, that there is also a T-Mobile signature in it, but it's highly unlikely that this will ever be used. And what RIM did was they put everything into the Java virtual machine. So you're not supposed to put native code onto a BlackBerry device. Of course, some people try. Okay, yes, I'm guilty, I did. But in general, that's the distribution you want Java code on it. So the Java, on the other hand, has tons of native interfaces into the RIM core, and is like the most evil API I've ever seen. I'm supposed to be quick, but I don't see Luis, so I'm gonna take a detour. There's, like, once I got an email from a Navy officer, US Navy officer, who said, there's this BlackBerry from another officer, and I need to track where this person is every time. Can you help me? And I'm like, nah, let's see what. And so I checked the API, and you can actually go and write a piece of Java, a really small piece of Java for BlackBerry, that registers a callback handler every time your BlackBerry changes cells. So every time your BlackBerry sees a different set of GSM cells, it will call back into this Java code and say, see, this is the new list of cells that we have, and those are the GPS coordinates to it. Even though it doesn't even have a GPS built in, it takes this off the GSM network. Very nice, because like it costs you less than 20 lines of Java code, and you got your mobile tracking, because then it can essentially call the API and say, send an email to officer XYZ at navy.gov or whatever, because I'm now here. So there he has his tracking. So it's very powerful. So how the code signing works, Java programs are distributed in a format that they call Sh0t. It's almost broken. There is a blog for research and for such from a Russian guy. He almost figured out how the Sh0t format works. It's not documented. The IDE, your programming environment, converts your Java file once you're done with programming into a Sh0t file, generates a SHA-1 hash of it, and then you have to buy a certificate and a PIN for the certificate from RIM. For that, you need a credit card. The idea is that when you bought a signature certificate with a credit card, RIM can, for any binary they find on their platform, tell who wrote it. Which, of course, assumes that nobody ever loses a credit card or the credit card gets stolen. So RIM then signs your SHA-1 hash. RIM doesn't want to see your code. They don't only want to see your SHA-1 hash. And signs your SHA-1 hash, and everything gets rolled up into the Sh0t, and when it gets loaded into the BlackBerry will verify that everything is nice. The thing is, you can also load unsigned binaries into the BlackBerry, depending on some settings that we're coming to in a minute. But as soon as you try to instantiate a class that is provided by RIM, and not like Java lang something, you actually need to have the valid signature. So what they say is you can calculate 5 plus 3 and put the result into a string variable. We don't care, you don't need a signature for that. If you want to talk to the phone, if you want to display something on a display, if you want to do anything, it has to be signed. So this is how it works. In reality, it also works. But essentially, nobody cares. Because there's just not enough interest in breaking this, and if somebody will care, they will get a stolen credit card, or as someone else showed, in the US there are prepaid credit cards that you get in the convenience store. So you can go put $100 on the table, get a Visa Electron anonymously, and then use that one to buy your RIM signature, so it won't help them shit. So, code signing on the iPhone. Apple obviously does not plan to actually make the phone really open, so as they are with everything else in their portfolio, they don't care about third-party apps too much. They think Apple by itself is cool enough. So there is no SDK, there is no signature mechanism that they published, and everything, I think from the product strategy, everything is supposed to be in iPhone widgets. JavaScript foobar that runs in your Safari vulnerable browser. So the signature checking, there is actually some signature checking being done in the bootloader for the SIM locking. We've all seen how effective that one is. The interesting thing is that, like, a friend of mine who, as his primary job, breaks the Windows Mobile bootloader, looked at the SIM unlocking code for the iPhone when it came out, and his only question was, guys, what took you so long? Because he looked at the signature verification code and went like, broken. So, other than that, broken signature loading code, there is no signature code set on the iPhone. So let's make a quick rundown on mobile phone attack vectors, just to cover them. So, as Microsoft discovered a few years back, everything that parses file formats is going to break, and the same holds true for mobile phones. This is just a small subset, like you have to parse SMS, you have to parse MMS, you have to parse ringtones, there are like 20 different types of them. You have to parse media files, more sounds, videos, images, all because they're in the MMS. You have to parse Symbian, you have to parse vCards, JAT files, email inline, web pages, proprietary foobar, and that doesn't even cover all the bullshit that you get over GSM. Now, you have GSM-specific vulnerabilities. Does everybody know here that the A5 algorithm, the unpublished algorithm for GSM over-the-air encryption, is almost dead? Like, it is pretty much broken. And there's a version called A5.3, which is more or less secure, but must be supported by the BTS. Now, the BTS is this little antenna thing that talks to your mobile phone. You can imagine how expensive that is to drive around the entire country and upgrade all the BTSs, because they don't have enough memory and CPU power to run a new algorithm. So they actually have to put in new hardware, which nobody's going to do. So in a very soon future, expect some hackers with like a bigger antenna attachment and some electronics on their laptops to actually pose as the basic transceiver station to your mobile phone and exploit vulnerabilities in your GSM voice codecs, of which there are plenty. Then, of course, you have all the other interfaces that your mobile phone has, like Wi-Fi, Bluetooth, IRDA. Does anyone still know what WAP is? WAP is still supported, and has anyone ever looked at the standard? I mean, like the WAP standard, like even the low-level standard is that much paper, like on top of each other. And so, like implementing the WAP gateway, the last WAP gateway implementation that I've seen was actually almost a gigabyte executable code, just like the executable code, to cover all the possibilities in the standard. It has everything that smells like broken, like variable length integers, ASN1 encoding, and 3 different types and forms, so it is totally broken. And then of course we have JVM outbreaks. Now, where do we expect malware? So we're coming back to the very beginning of the presentation. We're looking at the factors. So for Symbian, we have kind of platform factor. Well, we have different CPUs, different layouts. Really depends on the mobile phone you're talking. If you're targeting Symbian, the most effective will probably be Nokia Series 16. They have all the same phone, all the same CPU, that's fine. API is actually acceptable, you can do something with it. Bandwidth, well, GPRS is too slow to spread your malware. People would notice. Why would they notice? Not because your phone is talking, but your battery will die in an instant. Like your machine, your mobile phone will be offline after an hour or so trying to send malware over GPRS to other phones. UMTS will do, so UMTS is a good thing for malware. Waveline will do, but then again, it's too random. Most wavelines that you find that are open will actually bring you to captive portal and say, please pay. So nobody will do that. And the issue with Symbian is that most people will actually configure their phone to ask them for the connection. I've not seen anyone who takes like automatic connection selection, because if there's a waveline and you know it and you want to select it, if there is none, then you want to select your fastest connection like GPRS, UMTS, whatever, right? Everyone does that. And security and containment actually looks okay, but as I said in the beginning, I have no real clue about Symbian. And there are actually not so many stupid users because the phone actually is too expensive and only people who actually know what they're doing with their phone and why they need a decent web browser on it will actually buy a Nokia with the Series 16. Now on Windows Mobile, the CPU platforms are just too diverse. And you have very little indication if a user is actually a Windows Mobile user. Like on Nokia's, you know, if you receive the contact information on a V-card over Bluetooth, it's very likely that's Nokia because it even says that in the V-card. On Windows Mobile, well, they crash when you send them the V-card, so it's really hard to identify them for a malware in your phone book. And then the malware wouldn't know what CPU platform they're running on. On the other hand, the API is excellent. It's the Windows API, it's Win32. Bandwidth, we have the same issues, but we have another interesting part, which is the R API, which is the network protocol that they talk when you connect them over ActiveSync. Because then they expose another API that's called R API, which actually allows you to talk over the host machine TCP/IP directly into the Windows Mobile OS. The security is actually pretty good from a code point of view. The kernel is a beauty, I can tell you that. And stupid users, on the other hand, there are plenty. BlackBerry has an excellent common platform factor because that's what they really excel at. They make the hardware themselves, so it's all ARM7 TDMI. The API, on the other hand, it's in the JVM, as I said, and doesn't really allow you to do really, really sneaky things. Because like malware auteurs, as well as hackers, don't really like fully typed virtual machine environments because they steal you all the fun. From the bandwidth point of view, they don't even have UMTS yet. But they talk IP when they're cradled, so that would be the only time when the BlackBerry would really interesting. From the security and containment part, apart from the JVM, they have another feature which really saves BlackBerry users' ass, because everything that talks to BlackBerry is the best. BlackBerry Enterprise Server sits in your enterprise, or if you have a loser account, sits at like your provider. But everyone who has a BlackBerry usually has a company-issued BlackBerry, which means they're talking to the enterprise server that sits in their network, which is vulnerable by itself from back and forth, but that's not the topic of the talk. On the other hand, stupid users, we have plenty, but they're not playful. They only read and write emails. So it's really hard to convince them to do anything else. Now, let's talk about the iPhone. Common platform factor is the same. We have an ARM7. We have a Unix OS X API that every script kiddie can write exploits for. We have Edge or UMTS, by default or waveLAN, and it chooses automatically what is the best high bandwidth communication it can provide. The security and containment is like not even worth mentioning. We're talking about like Apple and a Unix system, everything running as root. So, I mean, if you have any doubts, go to the Metasploit SVN and check out like the latest version. I think you said 3.1 now, right? So, and well, stupid users, you actually have people that will still defend their iPhone as the coolest thing on earth when they have already 500 bots installed on it and can't make a call because all the GSM channels are taken out by distributing the bots. Now, ranting about that is fine, but I wanted to spend like at least 2-3 slides on how do you protect about stuff like that, because everyone needs a mobile phone, and especially in business. The key about protection here is you need central control, and it needs to be your central control. Like take a conversion, take your office infrastructure. Do you wait for your users in your office network to patch their machines themselves? Or do you allow them to run XP SP0 without any patches? I hope not. Do you allow them to write to like Windows directory or run as local administrator, surf the internet with like only IE versions? No, you don't. And you will also not even dream of outsourcing the patch management to a company that doesn't provide any SLAs to you. So, or would you even outsource the patch management to a company that will not even tell you when they're done rolling out the patches? No, you wouldn't. So essentially, you have to take control. Do it yourself. It's your data. The vendor will not protect you. The provider may, but on the other hand, think about it. As long as the GSM network can hold malware distribution, providers don't really have a real good reason to invest in preventing malware distribution over their networks. Why? Because it's their money. It will actually make the money if your phone sends spam or would actually distribute the malware to everyone in your phone book. That's not the case with email virus. That is still the case with mobile phone malware. And if the outbreak is not too big and they're not all over the news, it would probably, in some cases, and some providers say, well, you know what, we just shut and take another million airtime that we had this month. On the other hand, there is something like called SOX, for example, that requires your company to actually make sure that your data is not running around in the world. That includes your freaking mobile phones. So, there are only 2 platforms that allow you doing that, which is BlackBerry in Windows Mobile 2006 and upcoming. Well, Apple actually says that they're doing that, but they're like, you know, uses iTunes for updating. You know, they use a DRM music playing software for updating the mobile phone, which is not under your control. And I mean, seriously, iTunes, my ass, please. BlackBerry, for example, shows how to do it right. As much as I hate them from time to time, this is actually pretty good. It's part of the product since they rolled out the BlackBerry from since it is no longer a simple pager. There's a policy system that's managed via the BlackBerry Enterprise server, which you can push onto the device. So you can sit in your office chair and say, okay, I want to configure all the BlackBerries in the company on a high FIPS level, which means every data on a BlackBerry has to be encrypted. You can do that on the fly. You can, on the fly, say, I disallow any third-party code that's not RIM code to run on the device. You can even go into some details, like if the user uses a web browser and goes to a website with SSL or TLS on it, and the website presents an invalid certificate, which we all know, you know, the name is different, certificate expired, you can force the browser to disallow connections to that website, which we even dream of on Windows still. You can remotely lock the device, so if the idiot calls you and says, well, I'm not calling from my BlackBerry because that one is lost, because someone stole it, you can click on lock the device, and the next thing you do is click on wipe the device, and then whoever stole the device has hopefully only a blocked SIM card and, of course, the device, but not your data. And you can remotely update the software. Windows Mobile, and this is really hush-hush because I don't know if Microsoft actually published the plans to do that, but I know there is a, first of all, 2006 Windows Mobile, which you can buy right now on smartphones, supports device wiping and supports storage encryption, much as the BlackBerry does. Like you encrypt all the storage, and then if you have like 10 wrong passwords or something, it would wipe the device. But there's an upcoming product, and I don't know if it even has a name yet, an official, but it will support Active Directory inclusion, so you can actually push group policies into your Windows Mobile devices. So it's all pretty much as it were an Office PC. And from what I've seen, which is really little, it is actually probably even going to be better than BlackBerry, because that's the market they're trying to target here, and usually if Microsoft puts enough money on a problem, it will be successful. Was that fast enough?
Yes, sir.
Thank you. Any questions? There is tons of... Give them back. In the back.
Any questions? Go to the back. Talk to this guy. He's really smart, but he drinks beer. Now that he gave a talk, agora que ele falou, ele toma cerveja. Não é pouco. So, buy him a beer.